So our project is digital signage-based user-targeted advertising. And here myself, Lakmali, another two group members are Danushka and Tisanka. Right? So existing digital signage solution display advertisements without targeting users in front of the screen. But in our solution, we display the most suitable advertisements considering their age and the gender. Right? In our system, user detecting and identify unit captures the user and predicts the age and gender. According to that, best advertisement will be showed by digital signage control unit. With the smart power supply unit, you can turn on or off the digital screen by mobile app. The digital signage owner can upload the advertisements as Google Slides through the mobile app. So why we use Google Slide here is because of that we could reduce the cloud storage in our system, and the users can easily edit and look at a preview before saving them. Next slide. In user detecting and identify unit, the taken image from the camera is processed inside the RPI with machine learning algorithms, and the results will be updated real time in Firebase. Next slide. According to those updated agent information in Firebase, the best advertisement will be fetched from Google Cloud and will be displayed in the screen. Next slide. So these are the applications for digital signage control unit, which provides protection for internal devices, and the space within it is maximally utilized, and holes to get air into the fans are designed properly. Next slide. So these are the designs for user detecting and identify unit, where we place a camera additionally into the box, and the stand was also designed to place the camera. So in the stand, the length between jaws can be adjusted according to the table, and there's an adjustable hand to change the angle of the camera. And I invite Viraj to continue with features, functionality, and user experience.
Okay, here you are seeing the our backend, which is the Cloud Firestore, and this is our VNC viewer, and this is the SSH terminal for RBI. Let me run the code. And this is the image what we are using to test. So you saw that there were two people in the image, so it falls under the generic advertisement. So you can see it's now displaying the generic advertisements. So if you go to the Firebase, you can see all the corresponding fields are updated accordingly. So anyway, we know that the group by their age and gender, so we can use those details to use and create an analytic report. Something like we can get use those data to know whether the particular time, how many people came with this particular age and gender to the shop. Something like that, we can use those data. So this is the mobile application. So first, user have to enter their phone number and use the phone authentication to authenticate the mobile application. Once you entered an invalid number, it would display like that. So once you entered a correct number and the OTP combination, you would be redirected to the sign in with Google. So once you click the sign in with Google, you can choose any of your favorite Google account. So once you select the Google account, you can proceed. So here we created a progress indicator to indicate, like you can see right now, indicator to indicate that user that the backend process is happening. So here, after that, once you give the permission to turn on the location, you can see half of the form will be filled automatically. And those features we use to enhance the user experience. And you can see after you fill in the other missing information, you can hit next button to the proceed to the application, look into the application. So here, let's close this application completely and let's reopen the application. When you reopen the application anytime, you don't want to enter those information again and again because we are using shared preferences and Google Cloud Firestore to store the data. So once the user reopen the app, user will be directed to the home page. Let's go to the page to control. It allows the control access. Here, when you adding or removing a device, you have to use the serial number, which is the MAC address we have given. But you can see this is the way it looks like when you add a new device, but it is not very user friendly. So you can rename the device. So if you rename it like this and hit the rename button, it would be rename like this. So here, using this functionality, you can manage multiple devices from a single application. In this page, the bottom part of the page, you can see we have used all the UIs to enhance the UX. If you just select only the gender category and without selecting the age category, if you try to watch preview the advertisement, you cannot, like you can't. It alerts you to select the age category as well. So once you correctly choose the both age and gender categories, you can go ahead and watch the preview of the advertisements that you have placed. So here it opens with the Google Slides, as you can see. Then let's say I want to edit the generic advertisement. So what I want to do is just select the generic advertisements and click the add access button in here. So once you do that, you are asked to choose the Google account which you want to edit the slides. Then it open with the Google Slides. So you can click the slide you want to edit and go to the edit slide. Then let's say I want to play some random shape. So I'm gonna hit this plus button and choose the shape. So I'm going to add this rectangular shape. So once I add this, I have to save it. Then after that, I can X out and go to the previous pages uh, to the finally to the main page. So here you are seeing the green button which says user targeting is on. Let's say what if I I hit it again, you can see it's no longer user targeting. It uh, stops user targeting, displaying the user targeting advertisements. And once I hit again, you can see it automatically real-time updates the Cloudflare store and it start to display the ads with the latest changes. So here, this process happens automatically from the next user onwards as well. So let's go to the dashboard. So in this dashboard, we have created, user can preview the current playlist. If you hit that preview button, you can see the preview of that current playlist. So let's go to the profile page. In this profile page, you can see all the details that you have previously added. And if you choose the edit button, you can edit those details. And using the logout button, you can log out. Hans will explain from here.
And I will explain the smart power supply unit we have built so far. This is the hardware implementation of it. The digital screen will be connected through a 5-volt relay and it is triggered through a Node MCU Wi-Fi module and it is powered up using an AD converter, A to D converter through the main power supply. In the software implementation, we are using an MQTT broker to communicate the app with the Node MCU. For that, we are using, for the topic, we are using the MAC address of the Node MCU. And once the application publishes a message, which is on or off, the Node MCU will subscribe to that topic and it will trigger the relay module accordingly to control the read the screen. And the Node MCU board will be connected to Wi-Fi using the Wi-Fi manager library, which we have implemented for the user friendliness. And I will explain it in the demonstration. And here I have set up the smart power supply unit. And here is our Firestore console. And on the right side, we have the application. We have put some indicators for the smart power supply. When we turn it on, the red light will indicate that we have turned it on. And the green blinking means that the Wi-Fi is trying to connect. If it stops, it means we need to configure it to shop Wi-Fi at the beginning. So the users need to configure it using the Wi-Fi manager. For that, they can go to this. This is the power supply, the hotspot it created, and the shop Wi-Fi is here. And we need to connect this power supply to the shop Wi-Fi. So once you hit it, you will be directed to the power supply, the Wi-Fi manager page. So to configure the Wi-Fi, we need to give the shop Wi-Fi credentials and give the password, then save it. So when saving, the green LED will lit up. It means that it got connected successfully to the smart power supply. Now we are able to communicate with the digital screen by turning this power supply on and off. So here we will, if we go to the application, we go to smart power supply page. Here we can choose a smart power, the power supply we want. I have already added and renamed this device as shop front. And once I click it, we get the alert that it got connected successfully. And now we can publish messages through MQTT, so that when I hit this red button, the currently screen is off. When I turn it on, the plug socket will turn on automatically. And the page is also updated in the Cloud Firestore, and we can turn it off also. And another functionality I'm going to show is once the screen is on, and if we disconnect the Wi-Fi, then we don't have a connection. The green LED will start blinking. It means we lost connection, but the previous state is already there because the screen was on previously and it still retained. That is a feature we have added here. And once the connection is back on, we can see the green light blinking will stop. It got connected successfully, and now we are able to communicate with the device again by publishing messages easily. That's the functionality of that. And for the design, we are going to do this. This is a 3D designs we have did. We developed a compact structure, and we'll be screwing all components to the surface for solidity. And air vents are included to optimize the airflow, and also some clearance space included for connecting wires and cables. For the embedded system testing, we are going to take care of the the response time taken for the stability of the connection, because we are running machine learning algorithms. We need to run them as expected on the node hardware in a small time to get the expected results. And also there can be unexpected delays and reconnections we need to handle in this matter. For the user detecting unit, the response we need to check with actual crowd, because we have so far did with images, and we need to do it on real crowd and outside to capture the image quality if it's enough to capture people's faces, and also what is the best position for the camera for the maximum outcome. The test will be carried out using integration testing, and also some functionality tests with connection interrupts, and also validating the system through inputs. For the whole system's reliability, when the network failure occurs, the local saved advertisement will be played, and when the connection is back on, it will connect automatically and also updates real time. For the scalability, we have implemented three separate units where the users can buy multiple units or a single unit, and all of them can be controlled together using a single mobile app. For the security of the software side, we are using two-factor authentication, and we are using the MAC address uniqueness for the fields of MQTT topics and Firestore collections. For the
So allocated time
okay.
is over. Shall we move on to the
Yes,
Q&A?
I will explain the demonstration first. And the manual power on-off switches are also deployed in the hardware. And the demonstration plan, our procedure is to set up all the devices, and we will a person is detected in front of the identifying unit. It will identify as male or female. The signage unit will select the relevant advertisement category. Eventually, it will play the advertisement on the digital display. And these functionalities will also be shown on the demonstration. And that's the end of our presentation. Feel free to ask any questions.
Excellent, Prati. Can you tell us what's completed so far? Yes, sir. Okay.
We have implemented the smart power supply on the hardware we have already got, but we need to optimize it further with after 3D printing the models and placing the components solidly.
And adding to that point, actually, sir, we have to, since we have only one RPI, currently we use like threads to separate threads to run both signage part and user detecting part. So we are expecting to enhance this implement this actual two RPIs. So in that way, yeah, we have to still separate the unit like that way. So you're thinking of having two Raspberry Pis in the main unit? Yes, sir. Yeah, main unit means the signage unit and user detecting unit are going to be separated.
Right.
Actually, there are few.
For the display and the learning part.
Yeah, exactly, sir.
That's it, right.
Yes.
And actually, we have some sort of reasons behind that to separate it. If you want, we can, yeah, like that.
Yeah, go ahead.
Yeah, just kind of, because, when we're thinking about the best position to detect user and place the screen to the advertisement, it is not the same. Like, it depends with the Shopee structure, because there are some kind of changes, like the best position we might be at the doorstep to detect user, but the screen, to place the screen, the best position is not that same. Therefore, that was the reason, actually, that was the main reason to use two RPI, so then we can separate it. And then might be think that why can't we use the without wires? We can also connect with wires, but it's not also good when we're thinking about wiring that camera to RPI, like if it is a kind of considerable distance, and it's not easy. So that's the other thing. Actually, it degrades the captured frames quality and accuracy. And the other thing is like when we separate in this sort of devices, we can like we are running some sort of lightweight models right now, but we can improve it using some kind of good models. So in order to do that, we have to use sort of powerful uh, uh, powerful units like NVIDIA Jetson. So we can, without interfering to the signage, all the codes we have written, we can simply upgrade that user detect part with those powerful units. So in that way, it's better to have two units. That was the reasons, actually.
Okay. So now what I'm about to say doesn't apply to this particular unified project, but going beyond that, if you're say when you're talking about actually manufacturing a product like this, then you need to seriously think how to plan the actual circuit, the chip itself. So putting, say, a bunch of off-the-shelf, say, modules like Raspberry Pis in a product rarely ever happens for obvious reasons, right? So you just have too much redundant components that you actually don't need there. So it's great for prototyping and all that is there. Um, when you go for a real final product that is going to be manufactured, you would need to think about, say, for example, in this particular case, making a chip powerful enough to handle the running the trained classifier for face recognition and age detection or gender detection or whatever, and then running the display and other components in the system as well. So um, since this the classifier is there, you would need a lot of memory for your application. So say having your memory of the chip outside the processor on the board somewhere on the same circuit, but outside the processor, adds a significant amount of delays between the processor and the memory when you are trying to access memory. So you are much better off having them together in the same chip. So if you are going to design a chip for your own product, you definitely benefit more by having these two together. If you're accessing memory a lot, and if you're thinking of having a neural network on the chip, a trained neural network software on the chip, then obviously you are going to access memory a lot, and you're much better off having the memory on the same chip. So this concept of systems on chip is there. What I'm talking about goes beyond what we want from this course or the project, just for your information and satisfy curiosity if anyone is curious. I won't talk much more about it. Anyway, good job. Can you go back to the slide on testing? So this second bullet point, let's say user detecting unit response with actual crowd. How would you plan that test? How would you plan to conduct it? What do you need to think about when you want to test that?
So yeah, we need to think we can identify individuals in a video. We tried that, and when it comes to a crowd, we had some issues with not identifying them correctly. And in the testing part, we need to see what if there's a better position or how we can maximize the outcome. If we can identify 2 or 3 4 people, we can put a different ad category for that. We can accurately figure them out. And otherwise, we have gone for a generic advertisement category because we couldn't accurately detect multiple people yet. So we need to check if we can improve that using actually when you're doing it.
Right. Okay, that's it from me.
From me also, like you have done good work, and for this the same thing that you just told me regarding this video feed. I have a question whether you actually need to get a video for this purpose. I mean, someone should be standing and looking at the screen for a while, right? I mean, for him to display a advertisement. So uh, you guys are planning on getting captures or videos, both? Or
Yeah,
are you planning for a video?
yeah,
Yes,
yeah. We tested with both actually for the captures like we demonstrated, and of
Uh-huh.
course we tried with the videos how the face is like identified, like because videos the face is moving here and there,
Hmm.
because in actual scenario I think video is more close to the test, because the people, we cannot expect somebody to still stay still. There should be some movements, right? In the even the face movements there are some fluctuations like the position. So I think that's why we mentioned video.
Okay.
Yeah, that was the case. Yeah.
So for the captures, is it working?
Yeah, it's capture, it's definitely fine. Yes.
Definitely.
Yeah, it's working.
Okay. So for the user experience, what have you like added any features new from the I mean, after the previous milestone? Do you have any new features added?
Yeah, we added actually from the application side, we had not renaming part, right? Because we the actual scenario user has to enter that we are giving them unique serial, which is the MAC address. Then they, using that MAC address, they have to add the device. But when we dealing with that MAC address, it is very hard. Like, so we create that renaming functionality. So with that functionality, let's say if you are running the company with two floors, then you can see if you are by 2 RPI devices or power supply units, you can rename it according to the place that you uh, place actually. So then it is very easy, other than remembering those long 17-digit MAC addresses. That was, yeah, that was weird from the website. Yeah.
Okay. So your hardware part, how easy is it for a user to, let's say,
Yeah,
first
yeah,
once
yeah,
you buy the product? How?
yeah. So
yeah.
please.
Here we have implemented that Wi-Fi manager library I explained, because it is very easy for a user to configure to any Wi-Fi they want. It is not hard coded inside the Node MCU. And so, yeah, they can try and they can change it anytime they want using that Wi-Fi manager library. So that way they can change the connected Wi-Fi anytime.
So
they
they
want.
just have to connect to the Wi-Fi and
Yes, yes.
start working. Okay. Thank you. That's it from me.